Chapter 1, Lesson 4, Pre-Calculus, looking at building functions from functions. We looked at how to build new functions algebraically. We want to look at composing functions in this lesson. And composing functions, there's no algebraic equivalent for what we're doing. So it's kind of a new thing. We did it a little bit last year. And then, of course, we want to look at the domain of that new functions that's created by composing. Composing function is f composed with g of x, or fog and goff, as the way affectionately known. This little circle symbol is the symbol for composing, and what it really means is you take this second function here, g of x, and you plug a value into g of x, and we know that when we substitute an x value into g, the g function, whatever it is, it produces a y value. We then take that y value and substitute it into the f function. That's what composing is. So you substitute 3 into the g function, and let's say that produces a y value of 7. You then take that 7 and put it into the f function and get another value from there. So we're actually taking the range of the function and substituting it into the domain of the initial function. So really we want to look specifically, this initial function is the one that's really going to be used the most when we're doing fog and goff. We're going to take this entire function, as we said, and put it into the f function. And then when we look at the domain of this new function is really determined from the domain of the g function. And the g function is going to produce y values that we've talked about here that are going to be in the domain of the f function. Now what does that mean? Basically, here's what you're going to need to do. You want to determine the domain of this inside function, or this first function. And then we're looking for values from this domain that will be able to be used in the domain of the new function. So basically we're going to look at the domain of the first function, or the inside function, and then from those values determine which ones of those values are usable in the new function. Okay, so let's use an example here, and hopefully this can clear some of that up. So we have the f function is x squared minus 1. The g function is the square root of x. And again, what I usually do is I determine the domain of each function first. So the f of x function, x squared minus 1, is not going to have any restrictions on the domain. There's no square root and there's no denominator. And the g of x function are going to be values that are greater than 0. X, the radicand, must be greater than or equal to 0. Then let's go ahead and compose that function. So f composed with g of x means take the g of x function and put it inside of the f function. So I take this square root of x, which is the g of x function, and I put it in for the x in the f function. So that's going to give me x squared, or the g function squared, minus 1. The square root of x squared is x, so my new function is x minus 1. So this is the composed function. Now we want to determine the domain of this function. And again, we don't want to look just at this new function and do its domain, because again, this domain is being produced from other functions. So it's going to inherit some of the characteristics of these original functions. So the inside function is the g of x. So we want to look at the g of x. So the g of x domain is from all numbers 0 and greater. So what we want to do then is look at these numbers that are 0 and greater, the domain that is 0 and greater, or 0 into positive infinity. What of these numbers can be used in this function? Well, all of these values can be used in this function, because this function itself, this new function, does not create any new restrictions. So the domain of the new function is going to be the same as the domain of the original function, g of x. So the domain of the composed function is from 0 to positive infinity. Alright, so that's the example. Hopefully that helped. Let's do another example. So here we have the function x squared minus 1, that's the f function, and the square root of x is the second function. Again, we determine that the domain of the f function is all real numbers. The domain of the g of x function is numbers greater than 0 or equal to. And we're going to compose, and here the f function comes second, so the f function is going to be put into the first function. So I take this x squared minus 1 and I substitute it into the g function wherever I see an x. So when I do that, let's see what it will do. Okay, so we get the x squared minus 1 under the square root, or the square root of x minus 1. So what's the domain of this new function then? So again, the f function comes first, so we want to go to its domain, which is all real numbers, and we want to determine what of these real numbers can fit into this new function. Well, this new function has some restrictions because it has a square root symbol and it has a radicand. So there are going to be restrictions created by this new function that are going to place restrictions on the original domain of all real numbers. So we're going to need to determine of these real numbers which ones would satisfy this x squared minus 1, or the square root of x squared minus 1. So we go ahead and we set our radicand greater than or equal to 0. And because it's a squared, because we have plus or minus 1, what this means, remember, is absolute value. The values that we choose for x have to have a value that's larger than 1. So we're looking at, real quickly here, the domain numbers that we're going to use have to have a value that are greater than 1. So greater than 1 would be up this way, and a value larger than 1 would be this way. So our domain then is going to, of our new composed function, is going to be from negative infinity to negative 1 included, and then jumping over, going over to 1 here, going up to 1 and positive infinity. So when we're composing functions, remember we're taking the second function listed, substituting it into the first function, and then to determine the domain of the new function, we take a look at that first function that we're using, we look at its domain and determine which of those domain values will play or will fit into and can be used in the new composed function.